This is Think Out Loud on OPB. I'm Dave Miller. 3 years ago, the FDA approved the first gene therapy to help treat people with sickle cell disease. It was for patients 12 years and older. But what if you could use the same technology before someone was born? That's what some researchers and biotech startup founders hope to do. They want to use the gene editing technology CRISPR to change embryos during in vitro fertilization, and not just to prevent disease. Some people are talking about making babies that are taller or more intelligent. Ashley Smart is the associate director of the Knight Science Journalism program at MIT. He's also a senior editor at Undark. He wrote recently about what he called the accelerating commercial push to manipulate human DNA in ways that could ripple for generations to come. And he joins us now. It's great to have you on Think Out Loud.
Thanks so much for having me.
So CRISPR has been around, this gene editing tool, for more than a dozen years now. But part of the interest in editing embryos comes from some more recent technological breakthroughs in gene editing. Can you describe the improvements to CRISPR that were developed at MIT and Harvard?
Yeah, so CRISPR is a technology that was developed a little more than a decade ago now. And basically how it works, you can think of it as programmable molecules that scientists can deliver into a cell that will go and find DNA and make some change to that DNA in a very specific place. And the original versions of CRISPR could do this, but they'd often kind of make mistakes. And part of the reason was that how CRISPR worked was that it essentially have to hack the DNA into two pieces. And then those two pieces would have to be put back together again. Recent work at MIT, researchers have recently come up with a more precise way of doing it that doesn't involve hacking the DNA into. And so there are fewer things that can go wrong. And so essentially these newer versions called base editing and prime editing are just much more precise editors of DNA. People compare them to the search and replace function in a word processor.
Still, what are some of the technological challenges that researchers or companies will have to overcome if they're going to make viable, healthy babies from the embryos that they edit?
One of the big problems is that even with the more advanced forms of CRISPR, even with base and prime editing, these editors still sometimes make mistakes, meaning sometimes they edit DNA in places where scientists didn't intend to, or sometimes they make an edit in the right place, but they make a mistake when they're rewriting the code. And the problem with using DNA in embryos in this very early stage that many companies are interested in is that it's really hard to check to make sure that your editor has worked the way it was supposed to, because embryos are so small and so precious. You can't just do a normal biopsy on them to kind of confirm that your edits went well. You can pluck a cell or two, but sometimes that cell or two gives you a misleading picture of what actually happened. And so researchers are still trying to figure out if there's a way they can do these edits in early embryos and be able to confirm to test that they've made the appropriate edits before they start a pregnancy with these embryos.
What's the time frame that you heard from experts in terms of how long it's likely to take before this technology is ready?
It varies wildly. I mean, one of the interesting things about this area is that there are lots of views on how cautious or how ambitious we should be. And some people have said they think that within a year or two, this could be ready to go to the clinic, that embryo editing could be ready to do for a live pregnancy of a real human being. Experts more commonly that I've talked to have said 3 to 5 years or even longer. Some professional groups say that this is still decades away from being able to demonstrate that it's safe.
You pointed to an analysis from 2019 in which researchers estimated that in the U.S., there are likely fewer than a dozen births a year where the parents had genetic diseases in meaning that they could hypothetically benefit from embryo editing. So again, so this would be for genetic editing to prevent the transmission of diseases. It's an exceedingly small number, fewer than a dozen births a year. And in that year, there were more than 3.7 million births in the US. So can you help us understand that tiny number?
Yes, but I should also say that tiny number is controversial. Just how many families could benefit from this technology is still a point of a lot of controversy, and you'll see a lot of different numbers. But I think there's a consensus that it's fairly rare, and that's particularly when you look at the cases that are really the most compelling justification for using this technology. And so when scientists have talked about it, they've agreed that the most compelling case for using embryo editing is when you have two parents who have a serious genetic disorder or are carriers for a serious genetic disorder. And even if they did IVF, in vitro fertilization, every embryo that they produce, every potential child that they produced would also carry that genetic disorder. And so, for example, you could imagine two parents who both have sickle cell disease. If they want to have a child by virtue of their genetics, if they have a child naturally, their child will also have sickle cell disease. But also because severe genetic diseases are relatively rare in the population, and because it's even rarer that two couples both have a serious genetic disease, the the population of couples that fit this kind of very compelling justification for using this technology is small. That said, many proponents of genome editing, of embryo editing, say it's not only that population that could benefit. It may be parents for whom some of their embryos, but not all, would carry a genetic disease, and that number could grow into the hundreds or thousands potentially.
But the sense I get from your article is that biotech companies could use disease prevention, as you say, the most compelling cases for this technology, as a kind of ethical can opener for this technology. But once that can is opened, then they could start using it for whatever. What are they suggesting that it could be used for, or maybe even should be used for?
Yeah, I think you're exactly right. And that's something that a lot of bioethicists I talk to worry about, that this is really just an entry point into a slippery slope of using this technology to edit embryos, to edit babies in any manner of ways. And there are people who advocate for using this technology to edit embryos in any manner of ways, to make taller humans, to make smarter human beings, to give parents basically control over any trait you could imagine for their child.
You even note someone who talks about skin color.
Yeah, I mean, and that's one of the scary scenarios that bioethicists point to is that in a world where many traits carry so much social baggage, and that there's so many social pressures that stem from kind of our outward traits and outward appearances, that there may be pressure for parents to use this technology in ways that aren't really medically necessary at all, ways that kind of uh, perpetuate, the biases that we live with.
How do you think about the class implications of the potential use of this technology?
I think there are several implications. One that ethicists and a lot of scientists, for that matter, worry about is that this is really something that could deepen social inequalities. As with many technologies, uh, the first users are likely to be parents who have the resources and the wealth and the wherewithal to use a technology that's sure to be fairly expensive when it appears. And this could be a way of kind of baking in certain advantages to the lineages, to the children of these parents. One professional group warned that if gene editing were used for enhancement in this way, we could see a branching of human evolution. We could see essentially a new branch on the tree of life involving families who are using this technology.
What kind of research is happening in Oregon right now?
So Oregon, and specifically Oregon OHSU, Oregon Health and Science University, is home to one of, I would say, the two prominent labs that are actually doing research in this area, research on embryo editing. And in particular, the lab there at OHSU, led by Dr. Milapatov, was one of the first to do an actual experiment in which they corrected a genetic mutation in a human embryo. This was an embryo that was not used for pregnancy. This was being done for basic research, but they were able to kind of demonstrate at least a proof of principle of how this could work.
What kind of regulation for embryonic gene editing exists right now in the US? What is allowed and what's not?
So in the US, there are a couple of important restrictions on this research. There's restrictions on federal funding of research with human embryos. And so a lot of the work that's being done in this area is having to be funded privately or by nonprofits. But there's also a restriction, what amounts to a restriction on implanting implanting an edited embryo to begin a pregnancy. And so when we think about clinical work, when we think about actually using this technology in human beings to create super babies, if you will, that's still illegal in the US.
In the US does seem to be an important part of that sentence. How much are people, say American biotech companies or other people around the world talking about going to places where they don't have those same restrictions?
Yeah, I mean, that's one of the things that a lot of ethicists worry about is that there really isn't an international consensus on how to regulate this technology. There are some countries that have regulations similar to the U.S. That prohibit the implantation of altered embryos for pregnancies. But there are some countries that don't, or some countries that really don't have any stated policy at all. And so several of the companies that have expressed interest in doing this have also talked about going outside of the US to countries where the rules are laxer to do these experiments.
Finally, you wrote about a conference about this issue set up by a nonprofit called the Berkeley Genomics Project. It had leaders of various companies and other folks from the so-called rationalist community. What did you hear about the vibe there, about what people at the forefront of this are pushing for or talking about?
Yeah, the Berkeley Genomics Project, the conference that they held was very interesting because you actually had a mixing of very different communities. I think, you had kind of people who would consider themselves part of the rationalist community were involved, but you also had kind of prominent researchers from Ivy League universities who were there, all kind of coming in to talk about reproductive technologies, including embryo editing. Um, and my sense is that the motivations of the attendees were very different. Some of them are, very explicitly interested in using this technology to make smarter human beings. Some of the people there were more cautious, but I think all of them there were really interested in kind of accelerating the conversation about this issue. It's something, it's a discussion that's kind of been on the back burner, I would say. And I think they want to see it on the front burner.
Ashley, thanks very much.
Thank you.
Ashley Smart reported recently on embryonic gene editing for Undark. That's a nonprofit digital magazine about the intersection of science and society.